Good day, everyone, and welcome to another webinar in the series of Portunus solutions. We are aiming to safeguard the energy transition, and therefore we are producing this in order to educate the public on the context of cable failure and cable protection systems. My name is Nikola Krilovic. I'm from Portunus Solutions, board member, and I'm also an environmental scientist with specialties in general environmental science, the green transition movement, and infrastructure asset management. Today, I'll be talking to you about offshore renewables in the context of environmental and financial impact of cable fatigue and failure. We will be splitting this into two parts: Portunus white paper recap and the Portunus cable calculator, which we have recently developed. If you have any follow-up questions, do not hesitate to contact me via email at nicola@portunus.uk, and I'll be more than happy to assist. The white paper is something that we have been working on for the past few months, and it's a cumulative depiction of our expertise. We sat down and decided to put our own 2 cents and have various aspects in it. We ended up splitting it into 3 parts: the mechanical, financial, and environmental part. And the final product is now available on LinkedIn and on our website at portunus.uk. In the next section, we will be discussing the main points from it and hopefully trigger some discussion too. To recap the offshore wind industry in general, it's expected to be a significant contributor towards net zero, and it's an effective source of renewable energy because if we compare it, for instance, to the land wind farms, it's much more effective. Winds are stronger. There's no hindrances in terms of wind distribution, and also there is no not in my backyard effect, or otherwise known as the NIMBY effect, where people are bothered by it being in their vicinity. Governments, local authorities, and companies have recognized this, and therefore the capacity is expected to double in the next 4 years. But just because it's doubling doesn't mean we should not take into account everything that might happen that does not serve our purpose. So some things are still hindrances to the industry and might prevent it from growing and reaching its overall goal of green transition in the world. So for instance, the same thing can be applied now to assets in offshore wind. Offshore wind farms have assets both over and under the water, and cables are an underwater asset that's very important but yet overlooked, although it causes the majority of the problems with respect to asset damage. If you see the image to your right of the KIS Orca GIS portal, you see a typical offshore wind farm in the Atlantic, and the yellow lines represent this complex web of cables. If a cable were to fail, this means it would be a logistical problem to solve. Where did it happen? How did it happen? And how to solve it. But before we get to the damage, we need to make sure the cable is protected. The cable failure, if it happens, leads to costly transmission loss and also costly repair. The focal points of researchers dealing with cable failure is in terms of scouring, hence the scour protection implementation, damage during installation, and also cable fatigue. If you look at the orange arc here, you can see that this is a leeway that's allowed for the cable to tire itself out, become fatigued, and ultimately fail. Fatigue leads to failure, and we have tried in the industry before to explain this, but proper stabilization is the best way to control this. People have tried to do proper stabilization with rock dumping. However, this comes with its own problems, and it's actually exacerbating the problem. But if a cable happens, people might say, so what? Issues lie on numerous fronts, and the first one is the financial aspect. Offshore industry in general is already under significant pressure. It's a supply chain logistical issue. Regulations are constant. Geopolitics are a big player, especially if it's an international project. And inflation, further complicated by an already complex project and the growing rate of inflation in the past few years, is really putting a cynical perspective from the terms of investors and operators. And all of this is a problem even if we don't include the cable failure rate, which, according to academics, is 0.003 failures per kilometer per year. With each repair in isolation, it's estimated to cost at 9 million and can often go into tens of millions in costs if you include electricity losses. The philosophical question here, of course, is more unpredictable situations can be seen if more projects are started, and can we expect more failures to come? And this is a big question that needs to be on everyone's mind and something that needs to be prevented before it's too late. Aside from the finances, there is also an environmental issue. Usually, environmental health and safety standards make sure that all the issues that are covered by law are regulated, including the internal standards from the EHS. However, cable failure due to wear and tear is rather unpredictable and cannot as easily be regulated. By operators, it's considered an acute or a one-off problem. However, we think it's a recurring event, and the industry really needs to account for it, especially in terms of ecosystem susceptibility, emission generation, and also disturbance of the local biota. From an emissions perspective, every time a cable fails, a large vessel, a cable laying vessel, CLV, needs to be deployed. This action is fuel intensive, it's unpredictable, and not accounted for in general asset management. If it does happen, activity of cable repair can go on for months, meaning more emissions generated. However, by ensuring a cable is stable, we can minimize cable fatigue, and there is no need for intensification of cable repairs. Aside from this environmental aspect, there is also the ecosystem environmental aspect. First of all, we can treat cable repairs in a similar context to installation or decommissioning of cables by underwater noise generation, chemical pollution, sediment resuspension, and habitat reworking being significant problems in both cases. Some people who use rock dumping as grounds for a beneficial ecosystem tool, they say that it can benefit the local ecosystem because it provides a new habitat substrate. And it can be true in some cases, but it cannot be applied to 100% of the cases because there's always a risk of species invasiveness if the ecosystem is altered to the point of loss of benefit to the local biota. If you look at this diagram to the right, if, for instance, you introduce rocks, a completely new substrate to something that's not usually there, you might attract species that are benefiting from this new environment, and they might push out the species that have already established themselves there. And therefore, we cannot always claim with 100% certainty that rock dumping, especially for stabilization, can be ecologically beneficial. To conclude, in general, the white paper, operators and asset managers of wind farms need to consider external factors that impact their operations. If you don't, there will be increased maintenance costs, there will be loss of faith from investors and the public through social and environmental issues, and there will be decreased operational capacity, which defeats the purpose of a green transition and green energy source. So this really needs to be something to be considered. However, it would be not moral of us to claim that we have all the numbers and that we can claim everything with certainty, because it's an ever-growing field with very diverse wattages, diverse approaches, and robustness. So there is really limited data available. It's only settled case data that we have, and it's most likely the tip of the iceberg. So we do need better projection tools, and we are actively working on it. We have therefore created the Portunus cable calculator. The cable calculator, it can assist you in hypothetical scenarios and also highlights how the PSS can benefit the industry by limiting failure from fatigue, cable fatigue. And people in general need to know when working with data that if you want to consolidate data to make conclusions, you need to keep the variability in mind. Not every park size has the same megawatts. Not every park size has the same kilometers of cable per turbine, and price per kilowatt hour in euro or in any other currency can change. And therefore, we think this tool will really help benefit anyone involved. So if you go to portunus.uk/calculator, you can play around and see if it benefits you as well. Of course, we appreciate any input and will update the calculator with your requests. We think anyone interested in offshore wind can benefit from this, but we really think this is especially important to operators, business analysts, offshore wind professionals, and educators, as well as their students, in order to get a feel of how big of a problem this is and potentially come up with solutions and see what we at Portunus are trying to do in the context of this. I would really like to thank you for your time. If you do have any questions, please submit them either in the comment section or directly to me via email. I'm looking forward to receiving anything, and I'm always open for discussion. And until then, please stay tuned, and we will have more stuff producing on the way. And I wish you the best of days. Goodbye.